All right, so two things we're going to talk about today. The empirical rule, number one, and z-scores. Okay, those are your two things, two goals for today is to know what the empirical rule is and what z-scores are. All right, so show of hands, how many of you guys have asked a teacher to curve a test? Yeah, all right. That's what I thought, most of you guys. Now, let me tell you, I actually don't think you guys want me to curve tests, right? A lot of you are like, no, of course I do, but no, you actually don't want your test to be curved. And let me explain why. What does it actually mean to curve a test? Back in the day when professors would curve tests, right, they would make their scores fit into this distribution shown right here. This kind of bell-shaped, unimodal, symmetric curve. And that's why it's called curving a test. All right, so let me go ahead and explain this empirical rule and why you don't actually want tests to be curved, okay? So the empirical rule, first off, you can only use with that bell-shaped curve. And that's what we call a normal distribution, that bell-shaped symmetric curve. The empirical rule says that in the center of that bell is going to be the mean. Right? In the center of that normal curve is the mean. Now, if you step one step down, sorry, I'm like mirroring, one step down, okay, and one step up, right, 68% of the curve will fall within one standard deviation of that mean. Okay, so you have your mean, you increase, you go up one standard deviation and go down one standard deviation. In between, you'll catch 68% of that curve. Does that make sense? Yeah? Okay. Second one is if you go two steps, right? If I go two standard deviation above, two standard deviations below from the mean, I will catch 95% of the entire curve. 95% of the entire curve. All right, and the last one is if you go 3 standard deviations away. So you go 3 standard deviations up, 3 standard deviations down, you will catch almost the entire curve, 99.7. 99.7. So do you need to know these numbers? Yes, you need to memorize and know these numbers. In fact, let's go ahead and practice and memorize this all together. Okay, so go ahead and unmute yourself right now. Everybody, unmute yourself. Unmute yourself. Unmute, unmute. Mary, Jonathan, Nina, Jasmine, Diana, Jessica, Alan. Unmute yourself. Okay, Nina. There you go. All right, so repeat after me. 68.
68.
95.
95.
99.7.
99.7.
Okay, faster. 68.
68.
95. 99.7.
99.7.
Okay, all on your own. Ready, set, go.
68.
95.
99.7.
Okay, that wasn't terrible, actually. All right, so you guys need to know, you can mute yourself again. You guys need to know these numbers, okay? So know that it is 1, 2, and 3 standard deviations away from the mean. All right, so what does this mean with the curve? All right, so let's say I, your teacher, told you, student, that I did curve the last quiz. What that would actually mean is that no matter if it was an easy quiz, a hard test, if everybody did really good or really bad, no matter what, to fit it into the curve, 68% of you would get C's. The middle 68% would automatically get C's. All right, that's a blue region there. 27% of you will get B's and D's. That's that red area there. All right, so 13.6% of you would get B's, 13.6% of you would get D's. And then the yellow areas would be the A's and F's. So I don't think you guys really want me to curve, okay? Because I actually think you guys do better than what the curve gives you, all right? So like, for example, let's say our last quiz, the mean was 84% and the standard deviation is 4%, okay? What that would mean is that, let me see, 84%, let me type that in. All right, would be the mean. And if I go up 1 standard deviation, that would be 88%. And if I go down 1 standard deviation, that would be 80%. So according to the empirical rule, anybody that scored between 80 and 88%, you get a C. Yay. No, all right. And then B's, well, B's would be from 88% until 92%. All right. That means you, oops, 92%. Phil, let me go up. All right, 88% to 92%, you guys get B's. Not great, right? So I would just say be careful when you ask your teacher to curve. Make sure they don't actually use this curve. So when you ask your stats teacher, me, don't ask for a curve because I don't think you really want it. Your English teacher, who's your English teacher? What, Davidson, Shadell?
Mom Donnie.
Mom Donnie, okay.
Yeah.
If you ask your English teacher, yeah, go ahead and say curve because they don't know what that means. Okay. They probably don't. I didn't know before teaching this class. So when you guys actually, I think what you actually want is a rescaling. All right. So you would actually ask like, are you going to rescale the test as opposed to curve? Because back in the day, professors would actually do this to get a certain percentage of grades. All right, let's go ahead and try some examples here. Okay, let me see. Alan, can you read this one out for us, please?
I wasn't on mute this whole time.
Yes.
Oh my God. The height of a male student at San Marino is approximately normally distributed, which means 71 inches. Wait, I think I'm missing something. With a mean of 71 inches and standard deviation of 2.5 inches.
Okay, thank you, Alan. I kind of had a little bit of issues drawing on the PowerPoint. So you guys have the questions on your notes, so you can look at your notes. I'm going to share it from my iPad because it'll be a lot easier to draw these curves. You don't want to see me try to draw these bell curves on the PowerPoint. All right. So we have a mean of, I think it was 71, right? A standard deviation of, what was it, Alan?
And the standard deviation is
Wait, sorry, what was it, Alan? I missed it.
the standard deviation is 2.5 inches.
2.5, okay. So your mean is 71 and your standard deviation is 2.5. Okay. Part A, what was the question for part A? Diana, can you read that one? Diana Wang. Oh, Diana Wang, you're muted. Evan, you are not muted. Diana Wang? Diana? You see you're trying to unmute yourself for some reason, it's not working. Okay, Diana Liu, can you help her? What is part A? What does it say?
What percent of the male students are shorter than 66 inches?
All right, thank you. So shorter than 66 inches. Okay, so what you guys want to do is go ahead and draw a sketch. I think that really helps. So draw a sketch of your bell curve. Okay. And your mean is at 71. And now you want shorter than 66 inches. Okay, so 66 inches. Well, if I go one standard deviation below, that's 68.5. If I go 2 standard deviations, that's 66. And I want shorter than that. So I want this blue area right here. All right, and this keeps on going forever. Everybody still with me? Is that making sense? Yeah? Okay. So now I want to find that blue area. You have to use that empirical rule. So if I step out 2 standard deviations, what percent is in between? What was that number that we just chanted?
95.
95, good. All right, so here, this yellow area is 95%. Right, that entire middle portion is 95%. If I want to find my blue, what I'm going to do is I'm going to take the entire curve, so 100%, okay, the entire curve, and I'm going to subtract the 95. If I subtract the 95, that leaves me with both of these blue areas, right? But the thing is, I don't want both of them. I only want this left-hand side. So any ideas on what I would do after I subtract 95? Anyone?
Do you like divide it by 2 maybe?
Yes, good job, Avery. Yeah, it's symmetric. So those two areas would be equal. So if I divide by 2, that gets me just the left-hand side. So that's 5% over 2. So this is 2.5%. Okay, let me pause for questions.
How'd you know the 66 would be in that little corner of the blue?
So basically I took the 71, I subtracted 1 standard deviation. So Cassidy, how much is 1 standard deviation?
68.
Oh no, how much is the standard deviation?
What? What do you mean? Just 1 standard
It's
deviation?
a problem? Yeah. What is the standard deviation?
I'm not sure.
2.5,
Oh, okay.
right? So they give you the standard deviation is 2.5. So if you take 71 minus 2.5, that's 1 standard deviation below. If you do another minus 2.5, you get 6. So that's 2 standard deviations below.
Oh, okay. Thank you.
All right, Evan, I'm going to mute you. Okay. All right, let's try another one. Part B. Jeff, can you read this one for me? Because I don't see my PowerPoint anymore.
It's on the notes, right?
Yeah. So what is B asking us, Jeff?
Sorry. Is it the taller than 73.5 inches?
Think so. Yeah.
Yeah.
All right. So taller than, what was it, 73 point?
0.5.
Got it. Okay. So taller than 73.5 inches. So if I were to sketch 71's here, if I go up 1 standard deviation, I get 73.5. All right. So right here, that's just 1 standard deviation. There's that standard deviation symbol. Let me draw it a little bit better. There we go. All right, so I want taller than that. So I want this area to the right. Okay, so if I want that area to the right, well, let's go ahead and see what this area is first. If I were to go 1 standard deviation down and 1 standard deviation up, what percent is in between according to the empirical rule? What was that first number we chanted?
68.
Good, 68. All right, so 68% is this middle portion right here. All right, so then now I want this green piece. So to find this green piece, I'm going to, once again, I can do 100 for the entire curve. Take out the 68% in the middle, and that leaves me with both ends. But because I only want one side, I'm going to divide it by 2. All right, and that gets me 16%. Okay, any questions so far? Okay, I'm gonna have you guys try it, okay? So the last one, it's a little bit different, but it really, we'll see if you understand what's happening. So let me give you like 3 minutes and give the last one a shot.
16 plus 2.5
Okay,
to get.
you got to explain where you're getting these numbers though.
Okay, well, I took the 16% from B and the 2.5% from A,
Okay.
and just added it together and got 18.5, I think. And then I just did 100 because that's the whole. It doesn't really make sense, honestly.
Perfectly makes sense.
Okay, and then I just did 100 minus 18.5 and got 81.5.
Nice. All right, so let me explain why that makes sense. You did 100 minus 16 minus 2.5 essentially, and you got 81.5%. Let me explain why that actually makes a lot of sense. 100 is the whole curve, right? So this is the whole curve. 16, I'll shade in green, is this area right here to the right of 73.5. The 2.5, I'll shade it blue, is this area to the left of 66. So you did the whole curve minus the blue area minus the green area. So what does that leave you with? The red area. Does that make sense? You guys okay?
Can you just go over it like one more time?
Yeah. So it's very visual, right? The entire curve underneath is 100%. If I subtract the blue part, if I subtract the green part, aren't I just left with that red part?
I get it now.
Yeah. Okay. So yeah, good. I think that's actually the easiest way to do it. There's another way you can do it. Somebody from my first period figured this one out. What they did was they drew a line right here, right? And actually, let me do it in black so it's a little easier to see. They cut up the red area because the red area is your answer. You want to find the red area. They split it into two pieces. And one standard deviation away would be 68%. So they found that this piece right here is 68%. And then they found this piece on the left right here by doing 95 minus 68 divided by 2. And also got 81.5%. So that's another way you can do it too. You can like split up the areas. All right, cool. Any questions about using the empirical rule? All right, my advice, draw a curve. The visual, I think, really, really helps. Okay, let's go back to the PowerPoint. So we talked about empirical rule. Let's move on to z-scores. Okay, so your z-scores is, sorry, let me close that one out. A z-score tells you how many standard deviations away you are from the mean. How many standard deviations away you are from the mean. So the formula is you take whatever value you're looking at that you want to find z-score for, subtract the mean, and divide by the standard deviation. And hopefully that makes sense, right? How far away from the mean you are is your value minus the mean, divided by the standard deviation tells you how many standard deviations away you are from the mean. All right, so let me give you guys some examples here. So what do these z-scores mean? A negative 2.3 means that you are 2.3 standard deviations below the mean. You are 2.3 standard deviations below the mean. A 1.8 standard deviation, or sorry, a 1.8 z-score means that you are 1.8 standard deviations above the mean. Above the mean. Okay. And let me try, let's see, Alan. Let's say your z-score was negative 4.3. What does that mean?
That you're 4.3 standard deviations below the mean.
Yes, there you go. Nice. So that means you are 4.3 standard deviations below the mean. Okay. So the positive and negative represents if you're above or below, and the number represents how many standard deviations away from the mean. All right. So, well, why is standard or why is z-score important? Well, having a z-score is really important because it standardizes values. Okay, so let me give you an example and show you why it's really useful. Okay, so Will, can you read this one out for us?
Sally is taking two different math achievement tests with different means and standard deviations. The mean score of a test on test A was 56 with a standard deviation of 3.5, while the mean score on test B was 65 with a standard deviation of 2.8. Sally scored 62 on test A and a 69 on test B. On which test did Sally score the best?
Thank you. All right, so this is kind of like when you're comparing like your SAT scores with your ACT scores. You can't just take your SAT value and your ACT value and say, hey, I scored higher on my SAT because the number's higher. No, you can't do that, right? You have to standardize it to really see which one you did better on relative to each test scale. Okay, so that's why z-score is important. So let's find the z-score for test A first. Okay, so z-score on test A, you're going to take Sally's value of, what is it? 62, right? She scored a 62. You're going to subtract the mean of 56 and divide by 3.5. And that gets Sally's z-score. All right, and then do the same for the z-score for test B, right? Take her score, subtract the mean, and divide by the standard deviation. And I'll see what you guys get. Okay, Andrea, I'm going to go to you for z-score A. Evan, I'm going to go to you for z-score B.
Do you see annotation or?
Oh, just go in and tell me what the z-score is.
Oh, I have 1.71 for.
Okay. For
test.
test A?
Yeah.
Okay, and then Evan, what did you get for?
Can I skip on this one? Because this one I'm really unsure about.
Uh,
I'm kind of stuck.
okay, so do you have the z-score formula?
The one that's z-score equals x minus value minus mean over standard deviation.
Good. Okay, so for test B, what did Sally get?
For test B, Sally got 65 with a standard deviation of 2.8.
No,
so
but what did Sally score?
69. So,
Okay, and then so 69 minus, what's the mean for test B?
69 minus the mean.
Mhm.
65. Oh,
Okay.
so is it just 4 over 2.8?
And then divided by 2.8.
1.4.
Okay,
2.
so there we
1.4.
go. All right, so test A, z-score of 1.71. Test B, z-score of 1.42. So now you can actually compare. So she actually did better on test A. All right, she was 1.7 standard deviations above the mean, whereas for test B, she was 1.4 standard deviations above the mean, so not as high. All right, Evan, you good? Okay. Questions on z-score? All right, so z-score is nice because you can compare like apples and oranges, essentially. Okay. All right, let's go ahead and finish off your handout real quick in our last couple minutes, okay? So well, actually we might not be able to finish. I don't want to rush it, guys. Actually, you know what? Save this for tomorrow. Just remind me, okay, that we still want to fill out these blanks. All right, the lesson tomorrow is pretty short, so then we can go ahead and just finish this up tomorrow. All right, any questions?